Time for a quick algebra break. I will keep these integral rules over there for foreshadowing, but right now we're going to go back and visit that fun time known as completing the square. That was one of the 4 different ways that you could solve a quadratic equation, but almost no one used it. It was the least attractive and required more work than anyone wanted to do. But it is just a way of factoring. So let me just review this because we're going to need to know how to complete the square for our next lesson. So I always use this special little rule. It was quite a funny little name here. I would always say when you're completing the square, half it, square it, send it. I know, that's a really horrible square, and most people don't even know what a letter is anymore, unless it's email. But that stands for half it, square it, send it. So what we're going to do is make sure that all the variables are on one side, all the numbers are on the other, and then we're going to take half of something. We're going to take half of that b value. If you recall anything about quadratics, we have ax squared plus bx plus c. So take half of 10, and hopefully that is 5. Square that number, and then send it to both the left-hand side of the equation and the right-hand side of the equation. So the whole point of this, it's called completing the square, because when you factor this, you have a perfect square. Both factors will always be exactly the same. In fact, we'll write it this way because it's much easier. The whole point of completing the square is to take a normal quadratic equation and rewrite it so you have 2 factors that are exactly the same, a perfect square of variables. Okay? Now you finish solving it by square rooting both sides and then subtracting 5. We have our answer. That is the solution to the quadratic equation. However, that is not necessarily what we're going to be using it for. We're not going to solve all the way down, but we can use it to set up an integral. But just before we get to that, let's go to one more example. Let's see if we can complete the square. I'm going to write it slightly differently this time. I'm going to put y. Or if you like, you can put f of x on one side. We're kind of shutting off the left-hand side and saying, hey, this is our function. Let's just keep all our work to the right. So think about this. Pause the video for a moment. See if you can figure out what are we trying to have, what happens when we square it, and how do we send this? The answer you'll find is ugly fractions. When we take half of it, we get -5 halves. And yes, it's okay to keep that as a negative. Because in the very next step, when we square it, we get 25 fourths. And then finally, to send it, we could write 25 fourths on both sides of the equation, and that's fine. You'll just have one more step to do that. Or, instead of adding 25 fourths to both sides of the equation, what if just on the right-hand side we added 25 fourths and subtracted 25 fourths? You might say, why would we add 0? What does that do? Well, it just so happens that when you do that, there's been a net gain of 0, but you can still complete the square. You can still complete the square, and it just so happens that if we do that, I don't know if you noticed, whatever you have, that's exactly what's going to be inside your perfect square. In addition, we'd write this as 24 fourths. We get an answer like this, but I'm mostly concerned with, do you remember how to complete the square? Because that's what happens in the next video when we want to simplify a really difficult integral. We'll pause here, and on the next video, integration. Bye.